Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to discuss Lami's theorem. We spell it as Lami, and also conventionally we write it as Lami. But actually it was a French scientist, Bernard Lamy, Lamy. Who was Bernard Lamy? Bernard Lamy was a French scientist who gave the law of sines for trigonometry applied to vectors. According to this law of sines, if you have three vectors A, B and C, their sum must be equal to 0. And the result of this sines law was A mod over alpha, B mod over beta and C mod over gamma. A, B and C are the three vectors, and as a result, three forces A, B and C. These are the three magnitudes of these three forces A, B and C, and alpha, beta and gamma are the three vectors between these three forces. Now, what is Lami's theorem? Well, according to Lami's theorem, if three forces acting at a point are in equilibrium, then each force is directly proportional to the sine of the angle between other two forces. Now, according to this definition, and as we call it three forces, we have already studied in the last class that these three forces must be coplanar, non-collinear and concurrent. So according to definition, if you have three forces acting at a point like this, F1, F2 and F3, the angle between F2 and F3 is, suppose, alpha. Angle between F1 and F3 is beta, and if angle between F1 and F2 is gamma, then according to Lami's theorem, if we take first force, suppose F1, that will be directly proportional to the sine of the angle between other two forces. Now, if you skip this force F1, the other angle between other two forces would be alpha. It will be sine of alpha. Now, if you remove proportionality sign, F1 will be equal to a constant into sine of alpha. On simplifying, F1 over sine alpha will be equal to a constant. So this is equation number 1. Now again come to definition. If three forces acting at a point are in equilibrium, then each force is directly proportional to the sine of the angle between other two forces. We have taken F1 and it is directly proportional to the sine of the angle between other two forces, that is alpha, sine of alpha. If we take F2, that will be directly proportional to the sine of the angle between other two forces. Now, other two forces would be F1 and F3, and angle between them is beta. So F2 will be equal to constant into sine of beta, or F2 over sine of beta will be equal to a constant. This is equation number 2. Similarly, if we take the third force F3, that will be directly proportional to the sine of the angle between other two forces. Now remove F3 and the sign of the angle between other two forces would be gamma. So it will become sine of gamma. F3, on removing the proportionality sign, F3 will be equal to a constant into sine of gamma, or we can write it as F3 over sine of gamma is equal to a constant. This is equation number 3. Now if you look at all these three equations, equation number 1, equation number 2 and equation number 3, their right hand side is same. So if their right hand side is same, we can compare, we can equalize their left hand side. So therefore we can write it as f1 over sine alpha equal to f2 over sine beta equal to f3 over sine gamma equal to a constant. So we can equalize all these three forces. Now if you have three forces acting at a point in equilibrium, then you can find any of the unknown force between these three forces. You can equate all these three equalities, or you can take any of these two. Now let's have a look at why we study Lami's theorem. Well, firstly, it relates the magnitude of coplanar, concurrent and non-collinear forces that maintain an object in static equilibrium. Secondly, this theorem is used to analyze most of mechanical as well as structural systems. Now, what would be a structural system? For example, if you have a load hanging with a string like this, and that string is knotted with two other strings at point O, and tension will be in this direction, and those two strings are hooked up in the roof or wall of a building at certain angle theta 1 and theta 2. So this is a three-force system on which we can apply Lami's theorem to solve or analyze the forces in these three strings. There are some limitations of Lami's theorem. Now let us have a look at limitations of Lami's theorem. Well, according to Lami's theorem, there should be only three forces. Number one, there should be only three forces acting at a point or on an object. Number two, these three forces should be coplanar. These three forces should be coplanar. Coplanar mean they must act in a single plane. Number three, these three forces should be concurrent. Now, what are concurrent forces? We have already studied in our last class that concurrent forces are those whose line of action meets at a single point. Number 4. These three forces should be non-collinear. These three forces should be non-collinear. Now, what are non-collinear forces? Non-collinear forces means no angle between these forces should be 180 degrees. Like no two forces should be acting like this at an angle of 180 degrees. So this must not be the case in Lami's theorem. Number 5. These three forces should be radially inward or outward. Radially inward or outward. Now, what this mean? If three forces are acting at a point in equilibrium, the forces should be like this, radially directed outward or directed inward, or angle between them should not be greater than 180 degree. This must not be the case. And number 6, last but not least, these three forces must be in equilibrium. All these three forces acting on a body must be in equilibrium. So that's it, students. Thank you.